My name is Jaslyn Johnson, and this is my presentation. First mass analyzer is the quadruple mass analyzer, and this consists of 4 metal rods that create an electric field. It uses oscillating electric fields to separate the particles based on their charge to mass ratio, and the ions that do not hit the metal rods and are sent completely through are detected, and the ones that hit the rods are filtered out and not detected, and this is best coupled with gas chromatography, HPLC, or LC. The second mass analyzer is the time of flight mass analyzer. It separates ions by time without the use of a magnetic or electric field. Ions are sent through the tube of flight, and separation is based on the kinetic energy and the velocity at which those ions travel through that flight tube. It's also best paired with GC, HPLC, or LC. The flame ionization detector measures ions produced during the combustion of organic compounds. So each analyte passes through the flame, which then ionizes the carbon atoms, and these ions create a current at the detector's electrode that can be measured. And this is best coupled with gas chromatography. The photodiode array detector uses reverse optics, also known as the entire spectrum of light, and it captures the absorbance across this broad range of wavelengths, which allows for better peak identification and analysis across the entire spectrum rather than a small range or a specific wavelength such as UV vis, and this is best coupled with HPLC or LC. So some of the benefits of coupling the quadruple mass analyzer with gas chromatography: provides very high sensitivity, detects the low concentrations of these VOC compounds, and allows for the analysis of complex mixtures. With HPLC, it allows for the identification of the non-VOCs and drugs, and it is best for samples where sensitivity and selectivity are essential. With liquid chromatography, it's best for analyzing the larger molecules and polar compounds that these other two can't, and it provides fragmentation patterns that give the structural information about the compound. Coupling the time of flight mass analyzer with gas chromatography also provides high resolution, accurate mass measurements, precise molecular weight, and allows for you to distinguish between compounds that have the similar mass to charge ratios. Coupling this with HPLC enables identification of complex mixtures with little separation, provides higher resolution, and allows for the analysis of the non-VOCs. Coupling this with liquid chromatography allows for high accuracy for mass and sensitivity and provides better detection limits. Coupling this with the flame ionization detector with gas chromatography provides very high sensitivity when detecting those organic compounds, allows for the analysis across a range of different concentrations, and enhances the detection of the VOCs and semi-volatile organic compounds. Coupling with the photodiode array detector with HPLC provides absorbance data across the entire spectrum of light, allows for you to compare spectra to identify compounds, and using those multi-wavelength detections to compare that spectra. With liquid chromatography, it provides high sensitivity for polar non-VOCs and allows for the identification of complex mixtures as well as the comparison of spectra once again. The sample preparation for the quadruple mass analyzer for gas chromatography: the samples are vaporized to make them volatile, mostly using headspace analysis or solvent extraction. HPLC samples are dissolved in solvents, filtered, and then injected. And some of the major samples used for this type are the illicit drugs, explosive, blood, urine, paint chips, fibers, and pesticides. The time of flight sample preparation is going to be the same for the gas chromatography and HPLC. And some of the forensic samples are explosives, toxicology samples, synthetic drugs, paints, pollutants, and chemical warfare agents. For the FID sample preparation for gas chromatography, the VOCs are vaporized and injected directly into the instrument. Some samples may require a higher sensitivity, which would need more extraction or a different concentration. Some of the major samples are arson investigation samples, hydrocarbons, alcohol detection, or toxicology samples. For the PDA sample preparation for HPLC, the samples are dissolved in solvents, filtered, and then the samples are concentrated. And it is essential that you ensure the samples are compatible with the mobile phase being used. And some of the major forensic samples are the drug analysis, inks, dyes, toxicology, and paint chip analysis. And here are my references.